All right, so the last two examples, examples 6 and 7, are all about finding your domain and your range. And we're going to do that in set builder notation and interval notation. So remember, when you're doing the domain, that corresponds to your x values. So you want to look for the values that are going all the way to the left. If you have an arrow that's here, then remember, this graph is slowly going down and it's going to continue going more to the left. So that means it would be going to negative infinity. And this arrow is going to keep going up, and as it's going up, it's slightly going to the right. So that's going to be going to positive infinity. Okay, it's going to take you a long time to get to this other side here, but you are going to be stretching that out from negative infinity to infinity. So the way that we say that in set builder notation is such that x is an element in the real number set. And that's what we did last week. Now for interval notation, okay, all you have to do is use the negative infinity to positive infinity. And you might remember from last week that anytime you do infinity, you are just going to have parentheses. Okay, and interval notation is always going to include either your brackets or the parentheses, the hard brackets or the soft brackets. Set builder notation is going to be those fancy brackets. If you need to do the 3 or the E, that is fine. Okay, but set builder should always have the fancy ones. Interval is going to be a hard bracket or a soft bracket. Do you guys remember how to tell which one is which? It has to do with the circles. Okay, so if you have a closed circle, which is what we're going to have most of the time, it's going to be a closed bracket, and then you might have something with an open circle. Okay, that would be a bracket like that. Okay, and then your range, we are looking vertically. So if you have an arrow going down, that means the lowest value is negative infinity. The highest value is an arrow going up. So your range is going to be y, such that y is an element in the real number set. And now you see how we write that. It's just negative infinity to infinity. Okay, so based on what we did here, I want you to give B a try. At the very least, I want you to do that in set builder notation, because that is something that we did together last week. And please feel free to look back at your notes so that you can see an example of that. All right, so for B, your domain, again, is all real numbers. So if you're having trouble remembering that, again, you're always going from the lowest x value to the highest. So as this continues, right, you keep going to negative infinity. And as this continues in the positive direction, you're going to positive infinity. And so your domain is x, such that x is an element in the real number set. Okay, and then interval notation would be negative infinity to infinity. Okay, now for the range. We're going to find the lowest y value. What's the lowest y value here? Good. And I'm going to just mark it on here. So can you guys see that this is the lowest point on y? It occurs at -5. Okay, all of the other points are above that, and they go up to what value? Infinity. Okay, so this is going to be your interval notation. You're just going to go from -5 to infinity. So you can even write that down first. Always write the lowest value first. So what's lower, -5 or infinity? -5, so that goes first in the interval. Infinity should always go second. Negative infinity should always go first. All right, and then we're going to write that in set builder notation. So it's y such that, now remember, all the points are above 5. So we're just comparing y to -5. And are the values above it or below it? They're above, so that's going to be what symbol? What symbol we're going to put in between these? Yep, greater than or equal to. Okay, if they're below, it's less than. If they're above, it's greater than. Okay, they'll be equal to because you have the closed circle. You don't have any open circles there. Okay. All right, give part C a try if you haven't already. I know some of you have. That's excellent. Okay, so see if you can do both the interval and the set builder, but if you can't, just try one of them. Okay, so what's your lowest x value here? Negative infinity, right? This arrow means it's going to keep going to the left, so you have negative infinity. This arrow means you're going to keep going to the right, so it's positive infinity. So for your domain, it's going to be x such that x is an element in the real number set. And then I like to separate with the semicolon. Okay, so every single time you're doing the set builder and the interval. I'm just going to notate those so you understand the difference. Set builder, interval. It really does not matter what order you write them in, just as long as you have both of them on there. Okay, and then for your range, you always want to start with your lowest value when you're doing the interval notation. So what's your lowest value here? Your lowest y? -1. Yep. So if you just look here, right, you're at -1. What's your highest y? 1. Okay, so you would write that in interval notation as a -1, comma 1. You'd want to use the hard brackets because you don't have any open circles. Okay, and so this is in between two numbers. When you're writing that as an inequality, it's a compound inequality. It just means that y is in between -1 and 1. So -1 is less than or equal to y, which is less than or equal to 1. So you're going to do a compound inequality there. Okay, it's in between -1 and 1.
Am I able to do y such that 1 is that or is greater than y is greater than 1?
No, you're going to want to put it in that order. There are going to be times where we're going to connect them with an or, but you always want to start with the lowest to the highest. Okay, and then for the last two examples, the D and E there, remember last week we talked about discrete and continuous graphs. So A, B, and C, these were all continuous, but if you look at D and E, these are going to be neither discrete nor continuous because they have breaks in the graph, okay? But they aren't just points, so it's not just discrete. So in those cases, I do think it's a little bit easier to write it in interval notation first, so that's what I'm going to do here. And I'm going to start with the axis. So x is the horizontal axis. So horizontally, I'm going to figure out what my lowest x value is. Now, I have another arrow here, so this is going to keep going to the left, which means my lowest x value is negative infinity. I like to write these along the bottom. I think that helps me categorize them. Okay, now I'm going to find my highest x value. So my highest x value is going to be positive infinity. Okay, but the domain is not all real numbers. If it was all real numbers, it would include all of this here. But can you see there's a gap that's happening here? So it can't be all real numbers, okay? What we're going to have to do is use two intervals. So this goes from negative infinity up to 1, and then we have a gap. And anytime you have a gap, you're going to use a union. So we talked about that last week. The U is the union. And then it's going to pick back up here at 1, 2, 3. And then it's going to go to infinity. Okay, so whenever there is a gap, you are going to use a union. So when you do your domain, again, we're going to start with the interval notation. It's a little bit easier. It's going to go from negative infinity to 1. Soft bracket, hard bracket. We're going to connect that with a union to the second interval, which goes from 3 to infinity. Okay, so these are our two intervals for x. Okay, now we're going to write that in set builder notation. So in set builder notation, we're always starting with x such that. And we did problems like this above, okay? Like this one from 3 to infinity. This is very similar for negative 5 to infinity, where we had to say the greater than. Okay, with this one, you're at negative infinity. Is negative infinity above or below 1? Below. So we would say x is less than or equal to 1. And then do you guys remember what word this means? The U? It does mean union. There's another word. Or, yes. And then it's the intersection that means and. Okay, so this is or x is greater than or equal to 3. And again, I remember that because this means all the values are greater than 3. And so that's the symbol that I'm going to use. No, for this you want to do the or. So this is what it translates to when you're set builder. And then you use the union for your interval. So for the range, we're going to look at the y's. So we are going to look at our lowest y value. Okay, so I start down here. So again, my lowest y, I have this arrow, so it's going to be going down to negative infinity. What's my highest y going to be? So let's follow it up. So this is at negative 1. Is that my highest y? No, because I have this, and it goes all the way up to what? 1. Okay, so I write this just so you can see like none of the points are above that. Okay, and then we want to see if there is a gap or not. So if I were to continue this line, right? Let's pretend this pen is this line. Are there going to be any gaps in this graph? If there is, you'd be able to draw a horizontal line and it wouldn't hit part of your arrow. These are my two arrows. Are there gaps or do they overlap each other? They are going to overlap, so you're not going to have a union, okay? For if you're looking at this horizontally, that's different. So here, there's a no gap, okay? They intersect each other. So I'm going to say there's an overlap. There's no gap. Overlap, no gap. That means that there's a no union. Okay, so your interval is just from negative infinity to 1. So if they overlap each other, you'll only have one interval. If there's a gap, you will have two intervals and you'll use a union. Okay, and this is going to be y such that. And then if you have a number and an infinity, it's always compare y to this number. Is it greater than equal to or less than equal to? Less than. Anytime it's a negative, it's less than. Just ask yourself, is negative infinity greater than 1 or less than 1? So it's less than, so it's y is less than or equal to 1. Okay, and then for part E, we're going to do something similar. So again, we're going to look horizontally at the x's. Okay, so there's nothing here. This is where it starts. Okay, so can you guys label the intervals on the bottom and then we'll put them together? Okay, so on the x, this is going to be at 0, and then if I keep moving along, this is at 1, and then I do have a gap here, okay? From 1 to 2, it picks back up and then goes to 3. I always like to identify where my gap is so I know where my union's going to go. Okay, so then this first interval here is just going to go from 0 to 1. And we're going to do a union from 2 to 3. Okay, and then we're going to put that in set builder notation, so it's x such that. Now, if you have 0 to 1, right, there's no infinities here. Let's remind ourselves what we do in that situation. See how this is the same setup as this? So if you have two bounds here, the y goes in the middle, and then the numbers go on either side. Okay, so this is going to be 0 is less than or equal to x, which is less than or equal to 1. And then we have another one like that, so we're going to use an or. And this is going to be 2 is less than or equal to x, which is less than or equal to 3. All right, and then I want you to try the range, and then we'll check it together. see some of you writing the numbers on the side. Okay, so we should always be starting with our lowest y value. So now we're looking at the y's, the up and the down, right? I like to put my y's on this side, my x's here. So my lowest y value is at 1, 2, -3. Okay, and then that goes up to -1. Do you have a gap in here? Yep, you do. You have a gap this way. So there is going to be a union. And then it picks back up at 0 and goes to 1. Okay, this is not something that's mandatory for you to write on your homework. I would like you to write it for your notes so that you have that understanding of how these translate into your intervals. So your range is going to start at -3, go to -1. You always are going to write this from the lowest to the highest value, okay? So it would not be correct to write the -1 first. It has to be the -3 first, okay? And then same thing here. You have to start with the 0, and it goes up to the 1. Okay, so make sure you do those in that exact order. And then this is going to be y such that, and then again, you'll have these compound inequalities. So this is saying that y is between -3 and -1, or y is between 0 and 1. The reason why you need the or is because these can't happen at the same time. There's no number that's in between -3 and -1 and simultaneously between 0 and 1. So you need the or to connect them. Okay, so I'm going to show you what your homework is. All of 1.1 is due tomorrow, and so you're going to use the scan feature to turn that in. And I also wrote down on the calendar a reminder that there's no codomain or onto. So if your directions say that, just go to the directions that are in your notes. I use the example numbers that the book uses so that they should all line up to minimize any confusion with that. And I know we've done a lot of notation today, new notations and new stuff. Okay, so we'll have videos posted if you need to go back and look at anything. And remember that we do no penalty homework. So that means if you can't get everything done on time tomorrow, I won't penalize you for it. It'll be a star in the grade book. Like, it won't help your grade, but it also won't hurt your grade. But if you do all of the homework, I will give you points for it, and it can only help your grade. Do you guys have questions about that? Yep. That's okay. As long as you follow the directions and made a attempt similar to what we did in class, you're good. And by that, I mean, like, we're writing the domain and range. So you need to have domain and range. You can't just write down 5 or something like that. Okay? All right, good. Any other questions on that part? All right, then I'm going to show you where to find this stuff.